My name is Dennis Washira. A good Microsoft Run student ambassador and also a community lead on this user group. Today, we are continuing with our TypeScript 101 series, and we are privileged to have a presenter today who is our Microsoft MVP, um, Kevin Katumo, and also a trainer from Teach to Give. So I think let's give him about time as we get started, and also let's have an interactive session. This is object-oriented programming in TypeScript. Welcome all. Thank you, Kevin. You can take over now.
Yeah, thank you, Dennis. My name is Kevin, and today we are going to talk about object-oriented programming. But before that, let me just do a brief introduction about me. So, this is me. I'm Kevin Chomba Gatimu. I'm currently a technical trainer at Teach to Give. So basically, we do training sessions, and I'm also a Microsoft MVP on web development and Cosmos DB, and one of the leads at Kenya Data Platform. So if you want to join us, you can just search on LinkedIn Kenya Data Platform or on Meetup Kenya Data Platform, and you'll see us there. I'm also an outgoing gold. I don't know if it's seen. I made sure that today I wore the gold hoodie. Yeah. So if you want to connect with me, I'm quite active on LinkedIn. So my name is just there. My full names with the dash in the middle. Um, I'm also on Twitter, so at underscore Kevin Chomba without H. Yeah, and that's me. I'm happy to present on this series, which Dennis started about TypeScript, and it is an amazing uh, series of sessions. So I wanted to at least present one of these sessions and enjoy with you guys. So yeah, so if you're a fan of series, you can check out The Expanse. I like sci-fi series. It's my all-time series on The Expanse. You know, uh worlds beyond than those kind of things. Yeah, and I also love an animation known as Rango. Cool. So that's all about me. That's simple. And I think today, as I have said, before we jump to the VS Code, because that's the end of my slide, um, we shall talk about object-oriented programming, which a, is it a programming paradigm or a programming philosophy? Let me know on the chat. But um, so many things which you're going to talk about, you can use it on C Sharp, on Java, on C++, Python. Mostly, almost all programming languages, higher level programming languages, have these concepts, and they are so good, especially if you're creating backend uh, systems. You find that these things are the heartbeat of web applications. So yeah, we shall see how to do mostly these four things using examples, and see how we can do these using TypeScript, because that is what we are here for. So let me just bring in my VS Code. As I was saying, I use VS Code. I don't know what you guys use. Let us know on the chat if you use Notepad, Vim, or something like that. We would like to know. Uh, I have so many things open. Just a second. Mhm. Cool. So this is like my PPT in VS Code. Uh, before even we start coding or talking about anything, I think I'm just going to show you how I've set up um, my my environment, which I'll be running TypeScript, so that if you'd like to do it like that, you can just do it. But there is also another way I'll show you. So for whatever we are doing, um, if you just go to TypeScript TS Playground, you can still run whatever we are doing on the editor. So it's a cool place. If maybe you don't want to install things for, you just want to follow whatever I'm doing live, you can just go there and do these things, and probably need to add that there, and you shall be seeing the same things you'll be doing. And you can always change to whatever TypeScript you want. So so what I'm going to do is to show you guys what how I've set up these within like a second, so that um maybe you can learn something out of it. So let me just, I know my laptop is freezing a little bit. Um, just a moment. I open VS Code. So I have just gone ahead to create a folder on desktop known as demo. And then out of that, I have opened this folder, this VS Code inside that folder. I hope it is seen. I'm just going to zoom in a little bit for you guys to see well. So cool. I use PNPM. You can use NPM. It doesn't matter, whichever works for you. So to start a project, you just do PNPM init. I think also NPM init to get your package JSON ready there. So you can see one there. For these, because I'll be running TypeScript, I need it as a dev dependency. So I'll just do PNPM add dash capital D for dependencies, and then write TypeScript like that. I'll also need something to transpile my TypeScript back to JavaScript, something like that, or to just run the TypeScript. So I know Dennis uses TS Node. I uses TSX because I'm cool. I'll also need types. When you're writing JavaScript or TypeScript, there's a there's a dependency known as at type stroke node to just make sure when you're writing things which require just JavaScript, they can also be seen. Probably we don't need it, but hey, you can just use it like that and then press enter. So because I'm using PNPM, this will take a few seconds. That's the benefit of using PNPM. And there we have it. So I have my log file and my package. So now with TSX available here, I can be able to create my start script. So I'll be calling something, a file which are right there. But in the meantime, I'll use TSX to run that file in watch mode. Okay, so that will be a file like index.ts, not TSX. This is not React. So like that. Okay. Um, and I can remove the main for that. So with this is like my complete version of whatever I'll be doing. And we can just do a demo like index.ts. TS like that, and inside we can do um, console.log. It's not TypeScript, but it will still do the job. So saving that, running this will be PNPM. Run start. Let's see, and there you can see on the terminal we have our code. So the other thing I like doing is just putting these in my right hand side so that you can see the results and whatever I'm coding. So that's my setup, as simple as that. Okay, cool. That was not hard, but anyway. So that is where I am on this. Okay. So let me just bring back, because I have my notes with me here, an MD file. I like doing most of my things on VS Code these days because of switching back and forth, so that everything can be good. So this is my file. As you can see, if I open, my terminal is on the right hand side and everything is good. So let's talk about object-oriented programming. So I'll have some few notes here. I'll just go through them fast. I know you can find them online. So object-oriented programming is a programming paradigm, as I said, based on the concept of objects. And we shall see what objects are and classes. So TypeScript supports 100% object-oriented programming principles. And these are things like modularity, reusability, scalability, and those kind of things. And we shall see the pillars of the object-oriented programming and what is a class and what is an object. Basically, at the end of this, if this concept back in Campus did not sync, I hope it will sync and you'll be able to use it in whichever programming language you like. So we have classes. So I know this is the only definition we always get. Classes blueprints for creating objects. But always think of, like, you need a contract, and this contract need a document to showcase that the contract happened. So classes will be the contracts, and then the objects will be the physical evidence. So we shall always see the concept of classes being called blueprints, where if you have a blueprint of a house, that is a class, and then the actual house is the object, because using that blueprint, you can build 1,000 houses. So that's where this concept comes in. And this is a good concept. We need to understand it and see how we can use this. So to just start with, I think we shall define what a class is, and I don't know how I'm going to. Let me just say this. Uh, no, just give me a second. It's been a while. I want to arrange my screens better. Okay, so cool. I think we all want to code. So just in case there's a question, Dennis, let me know, because I might not be checking the chat quite often. So I think we can just start by even doing the most basic so that we can see what is a class and those kind of things. I hope the screen is visible enough. So let me just get started. So I'm just going to run this index.ts pmpm start so that the file can keep reloading. So in TypeScript, the way we define a class, we use the class keyword. So I'll start with the simplest thing which everyone uses, like a person, I think, because it is relatable. So this is a class. As we said, it's a blueprint. So out of this class, it can have things we call properties and methods. So we shall see what is a property for now. And then once we continue with our presentation, we shall see other things. So cool. So a property is something like name, which can be of type a string, and things like age, um, which can be a number, like that. Okay. So using these are like the two properties. And you can easily get these properties by creating an object and use them. Okay. So what is an object? So for example, if this is a class, an instance of an instance of a class is an object. Okay. So probably I can create a person. Let's call them person one. This is just one person. To create a new class, we can use the new keyword, which is uh, a reserved word in TypeScript, and then call our class by the class name, which is person, and then instantiate it with the two brackets like that. It's like a method, but just know we are calling a class. So by doing this, we have created an object known as a person. So for now, we haven't talked about construct and other things, but let's see. I think you can console log a class. I'm not sure. I've never done this, but let's see. So person, you see, we have console logged the person because it's still like an object in TypeScript, you know. So we have name and age as properties. So if I can do something like that dot to get access to the properties inside there, you shall see that we have this inheritance, which is showing us that, hey, the person object has two properties, which is name and age. So when we do that, it is still throw an error, as we can see. Yeah. So let's go ahead. Now we know what an object is and a class. Let's go ahead and explore more of these. And to do that, we shall talk about we have seen an object is an instance of a class. So they represent the entities which are specified properties and behaviors inside a class. So let's go more into properties, as we have seen name and age, and also do some methods and also try to execute this. So we shall start with just the class and then we shall go to a more detailed example. So as we have seen, these are properties. So we can create a method. So, and also we can use it. But before that, we haven't talked about a constructor, but a constructor is a special method which is executed as a first method every time we create an object. So we use the keyword constructor, which is a keyword reserved for this. And then, as I have said, it's a method. That's why you see we are trying to call it and we can do something inside there. I'm also going to create a new method, which is just going to use the two properties we have. Like Copilot is saying create. I'm just going to use that, but I'm going to implement it different. So I'm just going to say it's going to remember a method can return something. So it's going to return. I'm just going to use backticks to concatenate a string. I hope Dennis have done this in the previous sessions. So I think I did it in the wrong place. Uh, Let me just, come on. Yeah, okay. You know what? Okay, cool. Let me just paste that. So here we have greet, which is going to return. So the way we return something is the type of something is by doing that. It's going to return a string. So we are going to say hello, my name. I'm just going to use this string concatenating I think function. And the way we get access to this, because it is part of a class, we say a class is this. So we say this, which is this class dot name. As you can see, this keyword is this class. It has things like age, rate as a method, and name as a property. So this is how we have created a method. We also have a constructor, which we haven't used. I think it's the high time we use it. So a constructor, as you said, is just another method. So we can use it to accept things and even update things. when an object is created. So by doing this, you kind of reduce your workload of doing things like setters and getters, which we shall see um, using another example. But for the time being, let's just use it. So what I like doing is the things I'll be receiving here, they should match whatever properties I have, but I use an underscore to differentiate them. So I can say name of type string like that, comma, and underscore age of type number. And then once I receive these, how can I set them to my properties, which are inside my class? So as you know, every time you want to refer to these properties, you use the this keyword. So I can say this dot name is equals to underscore name, and the same goes to the age. So every time I create the class object out of these class, not out every time I create the person object out of this person class, I will be required to provide this as parameters. So as you can see, we have an error here because if you hover on it, it'll tell you TypeScript is smart. It'll tell you that, hey, we expect 2 arguments. Okay, and cool, person 1, we are going to give him a name. This should be Kevin. And then the age should be a number, so 25. So as you can see now, if we console log person.age, we are getting 25. Okay, console log is just a method to print something in TypeScript and JavaScript. Cool. And this is cool because we have just printed a property. How about a method? So I'm just going to copy this down and do person1 dot and then create. And then this is a method you have to call it. So we use these curly braces. And you shall see that we have hello, my name is Kevin, and oh, this should be age. Sorry. And these years old, like that. Yeah. So these are correct information. So most of the errors you'll find is that when you're trying to call a method and you're not providing the execution, like how you're not actually executing it. So you always find function greet. Okay. So this is not an error, but always remember to add those brackets to actually execute the method. So this is a simple method. We have seen a constructor. We have seen properties. We have seen a method. This is a class. And this is an example of an object. So you can have several objects. Let's say it's a blueprint. You can have the second person, John Doe at the age of 30. And if I just try to console log these guys, person 2, age, and even greet, you shall see now we have like 4 things which will be printed. One is 30 for John Doe, and then the message, then the other one. So this ensures something we called about reusability, and also we shall see things like encapsulation, how this happens, and even scalability. So this is cool. This will give us the foundation of whatever we are doing. And on this topic still, we shall see how you can still initialize your properties. I think I can do that. This is one way of doing that, and this, we're using your constructor to set them. But there's a shorthand for this. So by default, a property without something we are going to discuss, which is known as an access modifier, is by default public in TypeScript. Okay, so for these, I can still redo it in this way. Let me just show you. I comment that just going to retain name and age and say this is public name, public age, and then remove these. Okay, so if we can just clean these up, like that, the code should still work. Okay, yeah, the code should still work. It's the same. I'm not sure whether when you remove the public identifiers, that won't work, as you can see. Yeah, so you have to make them public or private or protected. Yeah, so this is much cleaner, but hey, you need to know that these parameters are doing the same thing which we did in the other example. So cool. These are the fundamentals of object-oriented programming. I don't know whether we have a question so far. None. So I think we can continue. Okay. So cool. Yeah. So that is a constructor and how we deal with it. We have talked about parameters. I have shown you the two different ways to do that, like the shortcut using this example here also. And access modifiers, that is our next topic. And by now I'm just going to use a more detailed example so that we can jog our mind. Cool. So this is a simple example. So from now I want us to use like a bank. So where we can deposit money and do those cool things with a bank. But before we go to that, I think we can start doing that in the encapsulation and inheritance part. But before we do that, let's still expand this person example and see how we can do things like we can use different access modifiers which we have. So I'm just going to return this to the other way, which is probably the the more harder way to read things. But hey, so these are public, as you have said, by default. So a public, come on, I can't write public. There we go. So a public access modifier actually means that this property can be used in this class and even extended classes. So classes which will inherit from these, they can use this property. So that is a public. It means it's open. It's a property which can be used anywhere. So let's say we have, people are so conservative in things like date of birth. They want to make it private. So you can think of something like date of birth. You want it to make it private. So let me just use okay, the DOB, date of birth, which can only be a number. You can't make it a string like that. So date of birth is a property which is private. That means it can only be used inside this class, but not even outside the class. So when you inherit this class or when you are doing other things like extending other classes to this, you cannot use this private. So this can only be used inside this class only. Yeah. So public is can be used outside this class. Yeah. So these are the two most commonly used access modifiers. We also have another one which is protected. So protected, we can say, let's say an ID number. Okay. So an ID number, like the Kenyan ID number. So this can be protected, But what means is that if we have a subclass which inherits from this class or extends to this class, can use this ID, but it cannot use this. So that's the difference between protected and private. So these are the commonly used access modifiers. And let's say we also have methods. So a method can be public. For example, this is just public without saying something like public. In front of it, it's public, okay? And we can also have protected and private, okay? So let me show you just an example of a private get date of birth, of course, which is the number it's going to return this. So what happens is that these get date of birth will be private and it can only be called inside this class. So let's try to call this. So we have, I think we should, let's add more of this. This would be this dot date of birth, 1995, this dot ID, something like that. Cool. So let's try to access date of balance here. So we have, I think we can just console log. Let me just comment this. Console.log person. I know we shall have errors, by the way, because we need we need to provide this. I don't want it to be option. I want it to be required and also an ID required. So we shall have errors. That's what I meant. So because we have two more properties, we have assigned them and we have called them inside the constructor. So we need to make sure that inside here, we're also providing them like that. Cool. And here can just, hey, that's an odd person. So let's just do 2020, 20,000. Cool. So let's try to access get date of birth. So this will be person. Let's do person1 dot, and as you can see, as expected, we can't access it. Okay. As you can see, we only have age, greater name because this is private. It can only be used inside a class. That's why you see we are also getting an error. It's saying it's being declared but never read because you can't read a private method via the object. So the only way you can use this is something like using these let's say years old. Probably we can remove this and say hello, my name. Hello. This sentence doesn't make sense. My name is that name, and I was born in this dot get date of birth. Cool. So that means that this private method can be called inside a public method. So when we call the public method, it has access to a private method and it can display its value. As you can see, we are just returning the date of birth, which will be assigned here. So this is not good because I just want to assign it direct here. That's why it was displaying private, but anyway. Cool. So let's see whether we can greet this person. So greet is there, execute it. Let's see. Yeah, and there you see, hello, my name is Kevin and I was born in 1995. Cool. So if you have a private method, it can only be called inside a public method. Something to note. But what about protected? Okay. Protected. Okay. Can we get access to get date of birth? Let's see. Nope, we can't. But if we are using another class we were inheriting from this class, we can do that, as we shall see in our next example. So I wanted to cover that to just make sure we have seen the actual private, public, and protected in action, both in properties and both in methods. Cool. With that, now we have like the fundamental concepts between classes, objects, access modifiers, properties, and we can go ahead now to do something like encapsulation, um, which encapsulation is what we have also been doing, only that's maybe probably you guys didn't know. But if I can just read some definition about it. So encapsulation is the practice of restricting access to certain details. So for example, we have done private. So this is encapsulation. We are denying access of this property to some kind of level. So we are restricting the access. So if someone asks you, hey, showcase the concept of encapsulation, you can just give him an example of private and protected access modifiers, both in the properties and both in the methods. So that is the encapsulation. It's as simple as that. Okay. So I think let's use now a better example for what I wanted us to do. So we are going to do a class for bank account. So this is just to make sure we can remember most of the things we have covered. And by the bank class names in TypeScript, we like using a capital letter first. Some languages are strict on this. In TypeScript, I'm not sure that it's strict, but that's that's a better way of doing things. Yeah. So in this class bankrupt bank account, we're going to have a private we're going to have a private balance because we want to track our balance, which is of type number. And should we initialize it as 0 at first? But anyway, we can solve that later. And then we want to have a constructor, and this constructor should just set the balance to whatever we want. So probably I can use the short form. I think it will be better one. So and set everything well. So let me just call this balance and private balance number. And as we said, we don't need this so that we can have a shorter version. And in case you just want to initialize it, you can just do this is equals to 0 like that. Okay. And the cool thing with this is that let's say we create an object and say const M-Pesa account, which is equals to new, come on, back account, and initialize it with 1000. So if we can do a console.log on the M-Pesa account like that, and access, come on, can we access? What am I missing? Oh, this is private. Let's first just do it with public to see whether everything is okay. So do this, we are getting 1000. Cool. So let's continue with this. So we need to create a method to deposit, get balance, and even do other things. Okay. And we shall see how this is going to also inherit on other accounts. So let's do that. So what I'm doing currently by the it's inheritance. We shall see we have one class, and also we need another class. I think I can just by doing that. So we have two classes, one depends on the other one. But for this, we need to define the properties and other things. So the first class has balance as a number, which I think we shall just give it as a public. And also we need to have account holder of type string, like that. Okay. Yeah, so these can also be, let's just use public for now before I start forgetting things. Cool. I don't know whether this is readable well. Yeah, like that. So we have our constructor with those two properties we have initialized as part of our class. So the next thing we can do, how am I doing on time, Dennis? Okay, I see we are almost 54 minutes in. Okay. Okay, so we have this class. So let's create another class which is deriving from this class. So what this means is that when you have like a super class and a child class can inherit properties and methods or behaviors from the superclass. So we have a class bank account, but you remember in a bank or in fintech, you can have your main account and also have an account known as saving. So we shall see how this goes and how we can try to implement this. So before, let me just create this saving account. Extend is a keyword we use to extend or inherit properties from another class. So I'm just going fast to leave it like that. So we have two classes. Let's add more methods here. So we have our constructor. We also need a public. Let me just strong type things. So public deposit. Thank you, Copilot. And the only thing we need to deposit, we need to come with amount. Okay. So we need amount somewhere there. And after we deposit, do we need to return anything? No. For now, we can just leave it. So the way, if your method is not returning something, you can just do void. So you can use the void keyword. So how are we going to deposit? So we are going to take our current balance by doing this dot balance, and then this is a short form. It's a JavaScript short form of adding something and then equating it to the same variable, if that makes sense. So that is what is happening here. So we are taking amount which you are getting from as a parameter inside our method, and then we are saying, hey, our current balance plus the amount we are getting, and then store that value inside the balance, okay, which was initially 0. So cool. So that's how we deposit money. So let me know, are you guys okay with this way, or should we just use the native way of doing things? Which one works? I want people to understand. I don't want to bring confusion on top of another. This is a short form for initializing properties in TypeScript. I think also in C#, something like that. Yeah, but let me just continue. So that is deposit. So what we are going to do next is simple. We are going to withdraw money. So withdraw. So these can be public. Should they be public? It's a topic of conversation, but hey, it's the opposite of this. We're just getting the current balance and minus the amount which you're getting. Cool. So we have two things in our account, two methods and two properties. So, and just to test these, const my account is equals to this, John Doe, deposit something, console.log, my console.log, my account dot balance to see I think the best way should be let me see, balance after deposit to make it sensible. So these, not these, but my account dot balance. That makes sense. Let's see. Cool. So after deposit, we are getting 150. Initially, we had 100. And I think we can just initial balance. Yeah. Cool. So initial balance was 100. After depositing 50 bob, we get 150. So that's cool. So let's continue. So let's say now you have a saving account. So I'm not sure. I'm not good in business standards, but just know a saving account is account which you use to save something. So it is extending the bank account. That means we can get access to some of these properties. So let's go inside here. It also has its own properties. So we can say something like protected for this case. And we can do interest rate. So there's interest rate. So if you're saving, there's that ratio of maybe adding more money in your account. This business stuff. So let's say this is our interest rate. Also, we need a constructor so that we can use some of the properties on top there. So constructor. So inside our constructor, we're going to define some few things. So we are going to get the account, some account holder, the one we had there. Let me just try to minimize this. So this account holder, let me just give it a string of type string, sorry, like that. And then we need balance. Come on. Yeah, balance of type string, like that. So we have two properties. We need to use them inside our child class. You can think of this as a derived class. And this is our in class, like that. Cool. So this is our constructor. We need to do something. As you can see, it is just crying. So for you to get hold of properties on our main class, we use this super keyword. So this calls the parent class constructor, if I'm correct. Yeah. So we can use super, and as we know, this constructor, the first constructor here, requires two things. So once we call it, we are getting access to those two properties. Cool. So as you can see, we are getting an issue here. The argument of type string is not assignable to parameter number. Cool. So that means I have defined something wrong here. So this should be a number. That's one of the benefits of TypeScript. So there is no issue with this. So now we have hold of them. I think we can also get access to interest in this class. And we want just to initialize it in our constructor. So I think we can just come here and say, I'm just going to use this, but with an underscore so that you can differentiate these. And you know what? I'm just going to use the native one. So this dot interest is equals to that. I'm calling it native, but it's like the old school way of doing constructor parameter initialization. Cool. So in our saving accounts now, let me just show you. Const my saving account. I didn't. Okay. What I wanted to show you is the access of this console.log my saving account dot. So as you can see, we have access to balance, account holder, deposit, withdraw. Okay, which is cool. These all four things are from the first class. I hope and as you can see, when we have the account holder, which is part of this class, which is because it is public. No, it's part of the other account, sorry, but it's still public. So so I think if any of these is protected, we should still get access to it. Protected balance account dot query. Oh, we have some issues here, but let me not fix them. Let's still first work with public for this to make sense. Okay. So public, we see we have balance, account holder, deposit, and withdraw. Cool. So I also need to add at least a method to calculate interest in our saving class. So let's do that. So we're going to call it calculate interest, and it's going to be public. So public, but then you can just not use public. Okay, so I know by now you know that. So calculate interest. We're going to return number on this. So what you're going to do is going to say that const interest. What do we spell interest? So this is going to be is equals to this dot balance, and then we are going to multiply our current balance with the interest. Okay, so that's how we calculate this. This is the only part we are doing maths. Cool. And then once we get the interest, we are going to add it to our balance so that we can get the total amount of money. So we're going to do this by saying this dot balance plus and equal interest. So cool. And then I think we should have just returned this, right? So by doing this, I think we'll be returning the actual balance, which is a shorter way of doing things. We're having some issues. I think it's here. So let's see. Now we have our extended class with a constructor, with a method, which is going to take my balance here on top, multiply it with an interest, which is predefined here, as 0.1 by default if we don't provide it. But if we provide it, it changes. And then let's see now whether we can calculate our interest. So my saving account dot calculate the interest like that. Okay, initial balance is 100, and then balance after deposit is 150. I think these are the these two things here, and then 102. So 0.02 multiplied by 150, and then the number you get, you add it to one. Is it 100? Let me just first remove these deposits. I think they are going to confuse us with maths. We are not mathematicians. So someone to tell me whether we are getting the correct answer on this. So we are taking 100 now. We are multiplying it by 0.12. We are getting a value. And then we are returning the balance plus the interest. I think that should be 102. Cool. I think that should be 102, if I remember my maths correct. So is there any question? So what we have done is just inheritance. We have inherited properties and methods by calling the super, because our first class requires two things in its constructor. So for you to inherit things there, you have to provide, or you have to call them. Actually, you have to call them and make sure that they are provided. So you have to call them using the super keyword inside our constructor. And then our also constructor requires you to provide the interest. And as you can see, by calling them means that you have to provide the balance and the account holder, which will by then initialize this class or create an object behind the scene and provide all those things. Yep, I think even using here, my saving account, we can deposit because we have access to other methods in our main class. We can deposit things. We can deposit 50 bob. And after doing that, we can also now calculate the interest. You shall see our first interest is 102. And then after depositing 50 bob, we get 150, and then 150 multiply by 0.02 and then adding it back to 150, we're getting 150.004. So I guess this is understood. So let's talk about polymorphism. So polymorphism allows objects of different types to be treated as an object of a common superclass. So what do I mean by this? So for example, we have our bank account, we have event display methods and other things. So how can we do polymorphism? So I have an example here. It's a lengthy one. I think I'm just going to grab it and use it here. So I think we are going to walk through it. It's a lengthy, but it's still talking about banks. So let me just use it here. Then I'll explain. So here we have the same example. We have a bank account. It has account holder balance, and we have them initialized via the constructor, and then we have a method to display the balance. And then we have checking account, which it's a class which extends our bank account. And then we have overdraft limit, which is a number. Okay, so and then we have our constructor here. Of course, I have already showed you how guys you can use the super to call that, and then we also need an overdraft limit, which we are going to initialize it here. So and then what we are going to do is to override the display balance, which was on top here. And then it's the same method name. So but we are using it on the extended class, and then we have new functionality with it. So what I can see here we are doing is that we're getting the account holder. Okay. Remember, account holder is in our parent class, and then our balance from our parent class, and then our overdraft limit, which is in our child class. And then we are creating accounts. This is easy. It's just roping new bank account, adding this, checking balance, this, and roping out through. So this is just displaying. So polymorphism, as I have said, allows you to use objects of different types to be treated as objects of common. So for example, the object which we create after in instantiating this class, it has a method known as balance. So we are trying to treat even the extended class, which is a child class, with the same method, but with a different functionality. So this enables a common interface for different objects. So we have, let's say we have this object, which is known as bank account, which is an instance of our first class. And then we also have a second object, which is known as checking account from this checking account class. And then for both objects, we can call the same method, but it will do different things, but it creates this interface to showcase something similar. Is someone having a question? Okay.
Hiyo kisha kupita imeisha hivyo. Anaeleza
Imani,
hizo class.
Imani, do you have a question?
No.
Okay, you are unmuted. I have heard you say hiyo ikisha kupita imekupita. If you have a question, I think that means there's somewhere you have not understood. So if you have a question, you can just ask. I'll just reiterate to it. But anyway, this is what polymorphism means. So you're creating a blueprint, you're creating a common interface or blueprint, which you can use different classes with the same method, but those two methods or three methods which are similar are doing something different. So I think this is the easiest way to explain polymorphism. Okay, so as I conclude, unless someone has a nagging question, we have tackled polymorphism, inheritance, encapsulation. The other thing is abstraction. But also we have abstract classes. So abstraction involves hiding the implementation and details and showing only the necessary parts of an object. So we have seen these in examples. I remember in campus, the lecturer used a class shape, which extends, no, class shape and then another class for circle to show this. But abstract class is something you should always note about an abstract class is that an abstract class cannot be initialized. So this means that you cannot create an object from an abstract class. And in TypeScript, it's easy. You just add the word abstract. Abstract in front of a class or in front of the class name to make it an abstract. So this should throw errors. As you can see, yes, you see we cannot create an instance of an abstract class. So abstract classes are used to just like create a blueprint. So what I'm just going to show you guys, I'm just going to create a simple abstract class. So this will help you understand abstraction. So let's just use a simple example for this. So we have a class known as shape, and we have this shape can have a color of string, and then we can have a constructor, and this constructor will receive color, and let's just do that. And then this shape, we can calculate an area out of this shape. So this should be abstract area of type number. And as you can see, we are not implementing this. So I'm just defining a method, the method name and the return type, but I'm not actually, I'm not implementing it. What I mean by implementing is by doing something like this, and then instead trying to do some maths, right? So you see, we'll get an error. You cannot have an implementation because this is marked abstract. So yeah. So something to note, even methods, you can't implement them. So you're basically creating a blueprint of kinda. So the other thing we can see is let's just do display color. I think that will be just good. Color like that, and we can't actually do anything with it. So like that, display color. I think we can just mark it as abstract like that. Yeah. So so with these, if I want now to use this class by extending other classes, that's the only time we can use this as a blueprint. So let's say we have a circle. Okay. So we have a class known as circle, which extends shape. So what happens with this? As you can see, this is a non abstract class. It's missing implementation for the members shape. So this means that TypeScript will help you understand that, hey, if you extend shape, all these things should be used inside here. Cool, and that's what we are going to do right now. So probably we can add something which is not there. For example, public radius, which is a number. And these will help us first call the constructor so that we can get access to those things on top. That means we shall ask for color, which is needed, and then we shall also ask for radius from our constructor, which is needed by this class, and then call super to provide a color, and then set our radius to the current radius here in our class. Then by doing this, now we can be able to implement other things like area, which was a method in our abstract class. So area for this will be easy to implement. It should return a number as we saw, and then it's just going to do maths.py, which is inbuilt method for getting the pi, and then multiply radius with another radius. Cool. And then with this we can get and also we can do something. As you can see, we have an error. This is telling us that, hey, you also have another method you have not implemented, because this is like a blueprint. You're using this blueprint to create another class. Okay, so we also need, and remember, you can only use the exact words, the exact method names and properties you defined on the main class or the abstract class. So display color will just take this dot color and console log it. Now you see the error is gone. So by doing this, now you can do const. Let's say my circle is equals to new circle, and then provide red as our color, and then 10 as the radius, and then console log this. Come on, my circle like that. Let me just open our terminal. Yeah, And as you can see, we already have our area here. Yep. So this is how you use, this is abstraction. You're using an abstract class to create another class. And this abstract class have properties and methods, but always know that these methods are not initialized. Okay. You cannot initialize them inside the abstract class. You initialize them inside the extended class. This is something close to interface. So even on an interface, you can do something like this. Just going to grab something. I know there's always a confusion between the difference between abstract classes and interfaces. I'll give you as a homework, but always know that an interface, you can use it to kind of describe objects mostly. It's used for objects to specify properties and methods, just the same way an abstract class does. So if I can just use that as an example, control for that, I can just grab, I have a simple example for interface. So we define, I know Dennis covered interfaces. We define an interface by saying, by using the interface keyword and then the name. And then as you can see, we have a property and another property and then a method. So let's use this interface to do something similar to what we have done with an abstract class. So we can have, this is a vehicle, we're going just to create a class known as car, which implements that vehicle. So let me just grab that code and show you as I end. So as you can see, this car has a blended model and here, but what is important is that it has start and stop, and even other methods, additional methods. And also we have an additional property, but the class is implementing vehicle, so it's using all these predefined properties and methods. So this is just a similar way, and you'll see when people are writing things like React on the front end, Angular on the front end, and Nest.js at the back end, you'll see, or Express, you see people using interfaces more than abstract classes, but they just do the same thing. It's just to describe how an object will look like. Yep. So that's it for me, guys. That's what I prepared. If you can test these and console.log, my car.brand, you shall see it's Toyota. Yeah, and we can even do things like start and call it. And we shall see we have an undefined our starting Toyota car undefined. So we have somewhere undefined, but anyway, that's how you do object-oriented programming in TypeScript using all the 4 pillars, that is inheritance, abstraction, polymorphosis, and the last one, which is encapsulation. So to just recap as we end, that's what I intended to do. I know there are others like setters and getters. We don't have time, but you can go and check about them. It's an easy concept, but I don't know whether people use it anymore, but I think it's an easy concept to use setters and getters to just set data to your properties and get data from either properties or I think mostly properties more than methods. Yep, so we have done encapsulation, inheritance, polymorphosis, abstraction, interfaces, abstract classes. We have not talked about static members, but you can go and check them. But also we have seen how you can add access modifiers, that is private, public, and protected. how to use constructors, how to initialize constructors. There are two ways, and the difference between properties and methods, class and an object. So unless there is an, I think if Dennis, I can throw it back to you. People are so silent.
Yes, Kevin.
Yes, that's it. I think I can throw back to you. So if you want to connect with me, that's me. I was so happy to be an MVP that day till today. So thank you guys for showing up. I can throw back to Dennis and maybe he has something to say.
Yeah, thank you so much, Kevin. It was an amazing session tackling about OOP in TypeScript, and I really appreciate I saw that the number did not drop that much. We maintain a constant of more than 20 attendees, so that means the event was successful, and I hope to see you guys um, next week. We shall be sharing what's next on this series. Um, Things are getting somehow advanced in this series, but I hope um, you are grasping something of help that will make you, uh, even if it's not an advanced TypeScript developer, an intermediate one, but move from a junior or basic TypeScript developer. So I want to wish you all the best as we continue. The recording will be shared later in our YouTube channel, and also if you want the code, I think Kevin can push the code to the GitHub and share the link with us. We have our WhatsApp group, Kenya Data Platform User Group. If you are not there, kindly make sure to join. Yeah, 1 hour, 30 minutes passed, and I think it is the best time to say goodbye.
Then
And yes,
I think I can share an MD file. I know you guys use MD files in real life. I can just share it on the chat. It has all the code examples and everything.
yeah,
I think everyone is able to access the chat. So in the chat, you can just go there, download it. If you open this file using VS Code, you'll see all the notes there, the summarized version, and I think you can